Graduate Design Week, a series of lectures. He will be back in this room tomorrow with Zaha, Inaki Avalos, and Jeff Kipnis when we will have the review of the graduate design candidates both on Tuesday and Wednesday. Greg Lynn is currently an adjunct assistant professor of architecture at Columbia, and before that he taught at Ohio State and at University of Illinois Chicago, if I remember correctly. I remember a few years ago, I can't quite remember what the context was, Greg, but Peter Eisenman was talking about young practices and young people and people who had been associated with his office, and one of the things that I think he mentioned was the fact that he didn't think that Greg should have left the office, I think. Greg had worked, I think, on the Cincinnati project and a few other things there. I think it's very difficult to try and predict, what would have happened if Greg had stayed with Peter, But I think what's for sure is that over the last few years, he's really done some remarkable work in terms of his own projects, his own teaching, and also the publications that he's been involved in. A great deal of his work has been involved with issues of topology and non-orthogonal spatialities, and he's really written on these topics in ANY, in assemblage, in a range of international publications. The list is really incredibly numerous. His office is also very busy right now. Greg Lynn Form is presently working on a house project. It's called the Hydrogen House for the OMV Corporation in Vienna, Austria. This is a project for a prototype house and visitor center for a large oil refinery on the outskirts of Vienna, Austria. All of the mechanical and electrical systems for this building will be powered by a combination of passive and active solar systems and a hydrogen gas fuel cell that is presently being used by the American space program. It also involves a great number of other highly inventive technologies that is being used on the glass to deal with the issues of transparency of this particular project. He's also working in collaboration with Michael McInturf Architects and Douglas Garofalo Architects on the Korean Presbyterian Church of New York in New York City. This is a project that's scheduled to be finished in 1997 and is presently beginning construction. Tonight, Greg is going to be giving a talk entitled Animate Form. And this is the examination of the role of the computers in developing techniques of temporal and spatial continuity and change at the level of a virtual device. By virtual, he means not merely the immaterial, but also the diagrammatic tools by which the concepts are actualized to create technologies which occupy the zone between the abstract and the concrete. Would you please join me in welcoming Greg Lynn?
Well, tonight what I thought I would do is do one part of what should be really a three-part talk. That's to keep the talk down to about 20 minutes. And then I want to show a few projects, 2 gallery installations and 2 projects that are actually the 2 that Moisen mentioned. To kind of set you up for the first 2 parts of the talk, what I'd want to do is just say that first off, architecture is one of the last disciplines that has a strong belief in Cartesianism. A lot of this is by necessity in terms of the construction process, but some of it is just by habit. I think the role of the computer in architecture presently is loosening somewhat that belief in Cartesianism, and there are at least 3 characteristics of computation that would make an attack on a certain Cartesian model of both space and time. I think those 3 characteristics, the first would be a lot of the computer software that architects are using now is based on topological descriptions of surfaces rather than Cartesian coordinate points in XYZ coordinate space. I think the second aspect of a lot of the computer software that architects are using right now is that the design is based on a parameter approach to design, meaning that often you're designing numerically, and those numerical design decisions are having strong formal and programmatic consequences. The third characterization of the software is that a lot of people are using animation equipment, which means that this is the first moment that architects have been using time-based tools or time-based animation tools in their thinking through of space. Now, I'm not going to go through the role that topology and numerically controlled systems would have on architecture. That would take too much time. So instead, what I want to do tonight is discuss a little bit the role of time and time-based techniques in terms of architectural design. The real reason for this is because for the last 3 or 4 years, I've been using animation software very intensively in both the courses I teach and in the office's work, but I don't think it's been adequately theorized. So one of the things that I'd like to do tonight, and this is a first try, is to theorize the role of motion and time in terms of the design approach, and to think through conceptually what it means to use animation software as a designer. The fundamental argument here would be that as architects shift from instruments of stasis to machines that describe motion, there has to be some corresponding thought, first of all, about the actual design process, second of all, about the experience of spaces produced with animation software. And I'll talk about that second of all. Now, there are at least two concepts of motion and time with which one could begin a discussion of architectural space. The first is very familiar to us. But before I get into that, I want to just talk about, when I say architectural space, I would mean that as a virtual space. This term virtual, I would borrow from Bergson, Henri Bergson, in his definition, where he uses the term as a kind of intermediary between the abstract and the concrete, rather than using the term virtual like a lot of historians today use the term in the sense of virtual reality or media. So the virtual isn't a replacement or supplement for the real, as in virtual reality, because that's too far simplified and too dialectic an understanding of it. Instead, what I'd argue is that the virtual can be understood as the territory between the abstract, meaning the infinitized and ideal, and the actual or concrete, something which is absolutely specific. So the virtual is the category of things before they become finite. More correctly, the virtual is the zone of actualization. It's the territory where things become described so that they could be actualized. In the end, it's basically the description by which something becomes actual. So it's about a process of becoming is really what the virtual describes. Now, in these terms, I think architecture is the premier virtual discipline. Instead of looking at the influence of media, photography, etc. on architecture, I think you'd have to say architecture for the last 2,000 years has been describing the virtual. And here I would borrow the insight of Robin Evans, where he argued that architects don't fabricate buildings, they fabricate drawings of buildings. And to confuse that is to confuse the issue of what we produce. We produce virtual descriptions of things which will be actualized, rather than actually making things. You know, the things we make are drawings, they're descriptions. So there would be two possible relations, as I said before, to the virtual in terms of motion. The first is very familiar, and that's the static position. Architecture has historically assumed that the virtual space of architecture is statics. And this banality is acceptable because the experience of real space is seen as dynamic. Architecture, it is often argued, is a conservative discipline. I wouldn't argue with this claim as much as I would modify it to say that architecture is one of the very last disciplines that maintains a devout belief in statics, that architectural structures should be static structures. And we think that's okay because we know that people move around in them, and we think they animate the structures with their motion. Now, if architecture remains dedicated to equilibrium, stasis, and the steady state, it flies in the face of what any structural engineer would tell us, and that is that all structures are dynamical in the sense that they're related to independent variables. Variables such as live loads, dead loads, wind loads, shear forces, earthquakes, etc. There's no single static or steady state that you calculate a structure to. You look at those independent variables and you try to generate a condition of stability, which is different, I'll talk about this later too, it's different than statics. So some buildings must be held down because they're so light they'd be lifted and blown away. Some must be buttressed from blowing over or falling over, and some must resist falling down. All of these aspects are things a structural engineer thinks about. Architects, on the other hand, think buildings have to resist falling down. There's a kind of vertical predilection, and there's a simple understanding of gravity as a dominant force when you think through space. And this is because of this belief in statics. And it's not due to a misunderstanding, but rather a fondness for the inert, or the timeless, that architects have. So, a static structure is a structure from which all of the moments and forces can be reduced numerically to a zero sum, or to the steady state. Each influence is compartmentalized or separated from the others and described discretely in relation to this zero sum. Time and motion are eliminated through reduction and idealization so that time can then be reintroduced at the end as a discrete entity within a static equation. Without getting too technical, if left in a state of irreducibility, these related independent variables could be studied in a continuum if one was to use calculus. I don't want to go into that, but the way you would study the structural behavior of a building is to use calculus, where you have a lot of independent variables seen in infinitely small durations, and you'd understand it in a continuum, rather than compartmentalizing and looking at forces in discrete ways. Okay, so this is simply to say there's a big difference between stasis and stability. Now, the reaction to this kind of an argument against the static is often to say, well then, a dynamic architecture would be an architecture of literal movement. And I would just want to pause a minute and ask if we really want buildings that move, or if that would really be what we'd consider a critique of the static. Now, the notion of a moving architecture might not be more interesting than an architecture which literally stands still. This is simply to say that the notion of the still or the moving is a badly formed question. It's just not the critical question whether buildings should move or not. It's a question of degrees of movement and establishing a theoretical structure by which to evaluate these degrees in movement, because in fact all buildings are moving constantly, even if you want to just argue they're constantly decaying. The idea that because all buildings are imperceptibly moving, architects should design static spaces is a strong theoretical idea, and it needs to be challenged by something as theoretically rigorous, which thinks through movement in potentially a virtual way rather than a literal way. That's tonight what I want to try to do, is distinguish between virtual and literal motion. Now, there have been a few radical discoveries in architecture in the last few hundred years. One is definitely perspective. Another is clearly calculus, and related to this are the studies of topology. But finally, the last development is the introduction of animation tools to architects. Following the introduction of perspective, the uses of animation in architecture are on a similar track. That is, an optical track. Most architects use animation to animate static spaces or to animate dead spaces. Now, this reinforces the relationship to motion I mentioned earlier, whereby spaces are designed in discrete static compartments and then later animated as continuous motion space using the fly-through. This reinforces the idea that architects design buildings as static using the tools of statics, and later make them dynamic and animated experientially by appeal to a mobile eye or the visitor. Now, the relationship here is one-directional. the building is static, the viewer animates it. This sets up a relationship to time and motion which begins with variables, reduces those variables to an equilibrium or timeless condition, and then understands that that is necessarily unpredictable once actualized. So you give up on the notion of working with the dynamics of motion and instead let it come back as an arbitrary movement of the viewer. This process, and I don't want to go too much into this, is the basis of phenomenology, is developed by Husserl, and it's termed iterative reduction. Now, iterative reduction I've talked about before here at the AA actually, and it's a three-step process. It's where you first define difference, or what Husserl calls alternations of deformation. You then compare those deformations and describe them with the geometry of what he calls the inexact yet rigorous, and then you eliminate those differences to achieve an ideal space. Now that's typically how motion is eliminated from architecture. Now the idea that Husserl had is that then, as an occupant or a viewer, by moving through a space in progressive times, you would slowly uncover the hidden static order of a space by eliminating all those differences. So Husserl understood that even though no two people would ever experience something real in the same way, by iteratively reducing that real to some ideal structure, they would start to perceive what would be the hidden or imperceptible ideal. Now that's a very strong argument about motion in space. It's that the space should be static, and the motion through that static space would slowly uncover that ideal timeless essence. Now, if this is the first model of motion in time, the second model of motion and virtuality would be one that tries to build, or to use Andrew Benjamin's term in the course he teaches here at the AA and at Columbia, would be to try to time the space, or to try to build motion and time into the space in such a way that it would trigger a more open and unpredictable experience of the viewer. Although, by definition, as Husserl said, there could never be two identical spatial experiences, even in something as reduced as the pantheon, where, say, you just have an axis and a privileged center, there is an assumption that there is a privileged virtual experience embedded within the architecture. Instead of positing this privileged virtual structure, it is possible to suspend the dynamics and the complexity of a space in a virtual structure which remains open and multiplicitous in terms of the experience of the space. Here it's important to understand the difference between the infinite and the endless, to borrow a term of Friedrich Kiesler's, as these two terms are often conflated. An infinite structure is one which is exact and totalizing, where an endless connotes a perpetual novelty within a limited set of variables. So that if you build a space based on independent variables without any privileged center, and as long as you have three of those variables, as Poincaré has argued, you automatically get an unfolding of a space which is never the same twice, but which still is delimited within a finite set. Thus, it's impossible to understand space outside of its history of becoming, because there's no ideal reduced moment in the design of the space. This is a simple but unrecognized fact in architecture and the sciences. This is a similar argument's been made about matter by Bergson, and that is that matter can never be understood simply by its components. It also has to be understood in terms of its history of becoming, so that the energy stored in materials is based on the history of how those materials were put together, heated, and conflated. Sanford Quinter would call this the intelligence of matter, and he's written on that in other places. So the history of matter, or the history of space processes, are recorded in the materiality as a kind of untapped energy, or untapped force. Using the analogy of a rock, its form and structure is contingent upon the temporal and situational forces through which it became. The heat, orientation, and force that fused the rock as a multiplicity of components into a singular structure is the same structure that can be unfolded or untapped to release that energy of its history. I think the same principles apply to the design process. So these same lines of fusion and becoming are the lines of release and experience by which one moves through a space and gains a kind of motion and force. I think a parallel term I'd want to introduce is a term invented by Bernard Kesch, who's a philosopher, architect, and furniture designer, who I think also has been around the AA on and off. And that's this term of the objectile. I'm sure I totally misused this term, but hopefully he would consider in spirit a kind of similarity. What Kesch argues is that an object is a static thing around which things move. A projectile is an object which is moved through space along a vector. So if those are the models of a dynamic and a static structure, the objectile is a structure which has a kind of dynamic stability, meaning that an objectile is something which has been shaped by force and stores those forces in its shape. An example would be a rock that's been weathered by the flow of water over it. The movement of water erodes the rock in such a way that the force of the water is imprinted into the stone. And if you take that stone and run water along it, the water follows those same pathways that have been worked into its surface. So that the inflections of an objectile are inflections of force, and those inflections can be re-experienced and unfolded in a certain situation. So that an objectile doesn't literally move, but it stores movement in its shape. It's a kind of motion shape, and that motion shape triggers a different kind of experience of space. So these motion shapes are objects that store their processes of becoming in their form. One could call these shapes landscapes, let's say. I don't mean landscapes like natural form, but landscapes which store motion in their surface and therefore make pathways and valleys that one would follow when moving across the surfaces. So I think curiously, if you could allow a conceptual definition of the term landscape and you could disengage it from the natural or the real landscape, it's probably a concept that could tie together a lot of diverse architects working with both topologies and motion. People like Foreign Office, Kipnis-Sherdel, Van Berkel, Reiser Umemoto, Carl Schuh, etc. I think if you had to say what's the characteristic of that work, you would say it's about treating space as a surface which is inflected like a landscape, and that those inflections generate paths of motion and paths of movement in the space itself. Okay, so now if I could have slides. Is there something I should do? Okay, well, while we're waiting for this, maybe I should say this a year ago was a two-part lecture on topology and parameters, and there was a gallery installation that I did in New York that we then moved to Oslo, where something happened at the opening which made me realize I had to develop some argument about the experiential component of the work. You'll see the space, but what happened at the opening is there's a kind of a dome that we built over an opening in a floor. And at the installation opening, we were looking down in the opening in the floor, and there would be 50 or 100 people moving in a clockwise direction, looking up into space, around and around, and then they would leave, and another 50 or 100 would come in and walk in the opposite direction. This went on for 2 or 3 hours. We were all trying to figure out what was going on, and we realized people were trying to find where to stand to understand the space, because they couldn't figure out what they were looking at, and they thought if they could stand in the middle of it, they would understand how it was all generated. Even though there were monitors with animations all over the place, they wanted to see what the structure of the installation was. And I realized at that point that although they weren't uncovering the process, they were basically tracking the space in a very similar way in which it was designed, as you'll see. and I started to realize these surfaces and volumes carry in them a certain kind of motion inflection which triggers people to move in a very similar way to the way in which they were generated. Now, there's no way that I could look at the space and understand the process. So it's not an argument about space and process where you can read legibly the whole design intentions in the final object. It's a very loose kind of relationship between the way in which something is designed with motion and the way it's experienced as a motion shape when it's built. But it's that event was the event that got me thinking about these kinds of surfaces and the experience of those interiors. So, are we close on the slides? Okay. Okay, so unfortunately, somewhere between New York and London, my videotape lost a lot of information. So this is an installation that was done in Artist Space Gallery in New York. I'd like to show you the video, but it's really bad quality, so I'll just show you the stills from it. There were 4 projects that I put in the show that were all competition projects that were done over a 2-year period. There was a Cardiff Bay Opera House competition, Port Authority Triple Bridge Gateway, which was an invited competition in New York, the Yokohama Port Terminal, and a study for a house in Long Island that we were commissioned to do. Those 4 projects we put in the display space, and then we took the Artist Space Gallery itself as a project and put that in. So there were five pieces in the exhibition. We took the gallery space, which, I'll go back to those. We took the gallery space, which was very eccentric, and when I went there to talk to Claudia Gould, who's the curator, about the installation, she said, "Don't worry, we're going to demolish the space and give you a clean box to exhibit in." And I said, no, leave the eccentricities because it gives me 5 corners to work, well, 4 corners and an entry to work off of. So we located each one of the installation pieces in one node of the gallery space. The software it was designed with is called MetaBlob or MetaClay software. And what you do is you define these primitives, which are the green volumes, and you define a sphere of influence around those primitives, which is the kind of translucent envelope. And wherever 2 envelopes of influence overlap, the primitive objects stick together and make a single surface. So the installation space had these 5 discrete nodes, but each one of those nodes stuck to the other nodes and generated one surface that we could use. So here you see that surface with each one of the nodes is a small case embedded in it, and it was hung on a series of plastic fins off the wall of the gallery space. This is before we put a surface on it. So we meaning, there were, I suppose, 4 of us with utility knives and this plastic stuff called Sintra. You can bond together, built the whole space in my living room in about 2 days, and shipped it and hung it up. The whole gallery space weighed, the whole installation weighed maybe 110 pounds and went up in about 3 or 4 days, so it was very quick and dirty. And then the boxes were translucent plexiglass boxes we lit from behind, and we put a series of these small models. I didn't want to try to do the strategy of building really big models to look like buildings, because I think that doesn't usually work very well when architects try to exhibit. So we built microscopic models with a technique called stereolithography, where you take a CAD file and feed it into a computer-controlled plotter that has a laser on it. And it shines a laser into a liquid resin, which is sensitive to light. So everywhere the laser hits the light, it solidifies the resin. Then when you get done, you pull the models out with tongs and just put them in sunlight for a day, and they bake hard. So the models were anywhere from about an inch long to a maximum of 8 inches long. So this is the installation space. I think I've got some details of the models. Yeah, that's the installation space at about 6 inches long by 3 inches wide that you saw when you walked in. That's a model of the house in Long Island. This, this whole issue of time and animation is, it was a huge problem for us to decide when we would stop a design study. Because basically, you can see here, there were maybe 300 or 400 frames in the analysis of this building prototype on the site. And the first thing we did is we just stopped at every 50 frames and printed it out and sent it over the email and got a FedEx package back the next day and looked at the 4 versions of the project and basically saw if there was one we liked better. And for a couple of years, this is the Cardiff model. For a couple of years, we were using the animation software to generate organizations that then we would have to freeze or we would have to stop. And I think in the last project I'll show you, we found a new way of working with the software where we weren't freezing it. This is a Port Authority gateway model. Okay, now we move the space. If I could get the video now. I think now that I've got some video, I can talk a little bit more about the animation process. The show moved to Oslo, Norway, where there was a space which was an opening between 2 floors in the museum, the Henny Onstead Museum. And actually, Johan Bettum, an AA graduate, organized the show, and he gave us this what was called the keyhole gallery, which was this opening, this keyhole-shaped gallery space, a floor down from the main floor. What was a problem, he gave us that because we would have really good light, but what was a problem is we were showing all videotapes, so we didn't want light. So we decided to build a light shield over the top of the space. The way we did it is we took those same 4 projects from the show in New York, plus a new project, which was this exhibition gallery, and floated them in the space with these fields of gravity surrounding them. Now, based on the location of each one of the elements to one another and the gravity field of this keyhole shape, they started to fall into repetitive patterns or orbits. So then we enlarged each project node to basically vault the opening in the floor, and we connected each node to the other 4 so that when they got close to each other, they would be torqued and twisted to attract to one another because we were trying to make a single volume using this Metaclay software. So that was a plan. This is a long elevation of it.
What scale is the plan?
What scale is this plan? The span of the space is about, not quite 30 feet. So this is about, it's 30 feet wide and about 40 or 50 feet long. This is the other elevation view.
But are you going to tell us here how you don't stop frame?
No, this is a do-stop frame project. These are those objects moving in that keyhole space. What we did using the animation software is, we set up dynamic situations, meaning we didn't keyframe the position of each object. We simply gave each object a force and a proximity, and then we just let the spaces develop out of that dynamic scenario. To fix things, we would have to then change parameters. For instance, some of those balls would go flying out into the gallery space, and we'd have to increase gravity parameters to keep them all contained in that volume. So, that's where we were designing more with parameters rather than surfaces. But once the points or the nodes began to fall into orbits, that's when we attached those large volumes to them. And we swept those volumes in the space so that during their whole history of movement, they would each make a contour. And these images are the captures of those contours as they moved in space. So we basically tried to take a kind of total outline of the movement of each one of those pieces and freeze it. Here, constructionally, what we did is we set up a series of aluminum tube sections that we post tension so that they would be flat in the space and white. And we put a Lexan plastic plane over it so it would continue the floor. And then we built these metal ribs that enclosed the volume of the space. When we got there, Gordon Kipping had built the whole frame, but there was you'll see it, I think, in one of the images, a huge Debuffet painting they didn't want to move. And so we weren't allowed to weld in the space. So we had to weld the thing on the floor and lift it into place, which, okay, you could stop that. So here's the space. We had to build it on the floor and lift it up. The object weighed maybe 500 or 600 pounds, but the wood frame they gave us to lift it with weighed probably more like 2,000 pounds. So in lifting it, we tore all the surfaces, and we needed something elastic. So we ended up using bubble wrap, huge rolls of bubble wrap that they had for protecting sculptures and paintings. So, but it was nice because in the space, the bubble wrap looked wet because it had all these little bubbles on it. It looked like it had dew. So this is a view from the lower level of the space, looking up into the keyhole. We took a series of intersecting solids from the space and dropped them down, and that's where the stereolithography models were displayed, and there were a series of interactive computer workstations where people could look at the projects from the interior, and then there were a few television screens where they could watch the animation process. But this was the space where at the opening, people were walking up and down the keyhole and looping at the end, trying to figure out where the privileged point of view in the space was. And they were always moving, they were always alternating, but they were always looping, which more or less is the way the project was generated in this kind of contained envelope with these objects following these orbits. The people experientially were doing more or less the same thing. Okay. Now there are two projects that we're building that I thought I'd talk about. A lot of these principles are happening here at a much larger scale, but I think the principles will hold true. This project also, the animation work is dead for, so I'll actually probably move through it a little bit more quickly. It's a Korean Presbyterian church that we're doing in conjunction with Doug Garofalo and Michael McInturf. It's in New York City and Queens, about a mile off the East River across the 57th Street Bridge. And it's an existing factory building, 90,000 square foot factory that was designed by Irwin Fenichel in 1932. And Louis Mumford lived right across the street from this building, and he called it America's best example of misplaced monumentality, because it's a two-story laundry factory, but because it's right now, this photograph is taken from the Long Island Railroad tracks, and because it's right on the railroad tracks, Fenichel put this kind of slightly deco modern facade on it to take advantage of all the people going by in the train, and he put a big clock, you can still see the clock, right in the center of the facade, so that on their way to work, everybody would turn and look at the building to find out if they were late for work. So it's been abandoned for about 6 years, and the Korean Church of New York purchased it with the idea of expanding a 3,000-seat sanctuary into the second floor of the building. What we found was that the roof slab was strong enough to hold a live load, so in the end what we did is we actually hung a sanctuary space over the top of the existing building and renovated the bottom 2 floors as a community center. The way we did that was using a similar technique of these metaclay elements, which I'm sorry I can't show you. We set up a series of seating studies where we defined local seating arrangements and connected all those objects into a single surface. and then oriented that single surface to the existing building. Here you see two volumes. The first is a metal shell, which is a standing seam roof, and off of that metal shell hangs a second object, which is wood and fabric interior that's more tightly articulated. So here's the diagram for the building, where you see the existing building in the kind of beige color. There's a series of trusses that span over the existing building. There's a metal shell which clads those trusses, and then there's a more articulated object that hangs within the space. The object, the sanctuary object that hangs, also droops off the side of the building and sets up a second entry. I can show you in the plans. This more or less is the very first conceptual study we did off the computer that shows the step truss system and the object hanging inside. I think topologically, this is a study model of that interior object. It's another model of it. I mean, there's a lot I could talk about in terms of moving from a topological description of space into a Cartesian one to do the working drawings and get it built, but it's probably too long a discussion. I think if you can see how the roof is smooth now. The big insight we had, the big insight we had when we go to the section was that initially we were building a surface that was more or less the same as this surface, but we were talking to the engineers, doing the value engineering about the economy of having each one of these spans be different, because there are 25 joists that frame in between each one of these trusses, and we wondered if it was enough to have 9 or 10 groups of 25 joists all at different lengths. And the structural engineers said we had to get repetition of 4 bay types, so that we would have to make 4 angles and then rationalize the roof based on those 4 angles. And it's because all of our columns were the same distance apart. Not because we wanted that, but just because it was a habit. So in the meeting, we suggested, well, what if we just set topologically this surface so as a surface, along a surface, it was always the same dimension in this direction, and then in a Cartesian cut below that surface, every column line would have a different dimension. And the engineer said, well, we always assumed you wouldn't want to change the column bay because all your dimensions would be slightly different. But in fact, we could care less because it's all done on computer anyway. So now the shell is basically a box. I mean, if you analyze it topologically, there's no difference between this building and a box, because every one of the members is identical, just like a box. It's just we're looking at the box as a topology rather than looking at the box as a Cartesian system. So it's not necessarily about opposing the Cartesian to the topological. It's about looking at what's a habit, a Cartesian habit, with a topological lens, and understanding that it's not about a debate between box geometry and topology, but it's about treating surfaces as surfaces rather than treating surfaces as volumes. Also, this is a roof plan. We reoriented the front entry to this side because there's a big open lot for parking. And for all of the demolition that we do in this area of the building to get 3-story spaces, we set up a series of splines and took the width of a column bay and swept those column bays through the building so that we get these curvilinear entryways, but we're always just demolishing between existing bays of the building. So we don't have to restructure any of that. This is the plan levels going down. This is the mezzanine level plan. You can see there's a mezzanine right here. There's a main new entry stair here. The elevators and stairways we clipped onto the outside of the building so we didn't have to demolish the slabs. And this whole structure hangs off the roof. This is at the main sanctuary level, where that piece that hangs turns and wraps down and makes all the entry walls that you see on the south side. This then is the first level of the existing building, which we really just define with ceiling plan elements. So there's a new kitchen up in that tower on the right. There's a 800-person cafeteria on the right with operable doors that open up to a 600-person wedding chapel, and then a big lobby to the south of that, and then offices along the existing south facade of the building. And then in the ground level, there's a 70-classroom school that's only used on Sundays, and a public assembly space for seminars, and it works as a chapel, and then a whole series of offices along the south side with a library underneath that entry stair. And this is a section where you can see the repetition of those truss elements, the metal skin that connects them, and then this faceted surface that hangs off of that structure. Again, I'm sorry I don't have the animations, but this surface, you get light and air in between each one of the facets, so that when you're sitting in the seats, it reads like a smooth space, but when you're sitting at the altar looking back, it's open up into that truss system. Then you can see the ceiling plane elements that hang down below to start to define the cafeteria and chapel at the existing level of the factory building. That's that interior. So that's looking back into the seats and up towards the mezzanine level. So you can see up in between those facets, and that's where the light and air gets brought into the building. So the ceiling stays pretty clean. Okay, now if I could get the video. This project is it's a visitor center and demonstration house for an oil company, the OMV Corporation in Austria. It's near the airport in Schwekat, and people pass by the Autobahn, you can see, is moving across the top of the screen. The refinery goes on about 3 times the size of this screen to the right and below, and the site for the house is right in that area. So because there's a hydrogen cell which basically takes hydrogen gas and puts it through a ceramic filter and mixes it with oxygen, and there's a controlled explosion. Actually, if you could pause this. Well, no, actually, you can let it run. There's a controlled explosion, and with the explosion you get free electrons as energy. You get a lot of heat, which you can use for running air conditioning and heating, and you get a lot of water vapor that you can condense and use as drinking water. So it's a zero input solution. Once you get it running, the sunlight can take that water and generate more hydrogen gas perpetually. So the oil company makes a lot of hydrogen gas in the refinement process and wants to promote it for a domestic fuel source. So to run this system, we needed to have a lot of photovoltaic cells. And what we did is, instead of studying the optimal angle for all the cells, we decided to study the position of the house and the position of the panels in terms of a moving sun across the site. So we set up a simulation where surfaces would expand when hit with sunlight, and they would contract when hit with shadow. And we just put the building where initially we were told the site was, and we studied 3 solstices of sun movement moving across the surface, which is also one of those solstices is what you're seeing here. Again, we were faced with the problem of where to stop, what's the best time of day that we wanted to freeze all the panels for. Did we want to do it at 1 o'clock in the afternoon or 12:30? And we asked experts when the optimal sun angle was. In the end, what we did is we put 36 suns in the sky at the same time to make a kind of solar vault, and looked at what it did to the surface. And we also, the clients asked if we could study other parts of the site, and after thinking about it, we just decided, well, you'll see, actually if you want to hit fast forward, you can speed it up a little. They look better faster. So then we duplicated this 4 times on the site and studied how it would deform. Here we moved it more towards the roadway. Eventually what we did, which is very cartoonish, actually, okay, if you hit, just let it play at a normal speed. we set up all of the sun angles and then drove the building around the site and asked them if they saw a place they wanted to put it. So you can see as it passes through the shadows, it flattens out, and then when it hits the sunlight, it expands again. There's a view where we put a camera at the back of the house and followed it around as it drove on the site. It's coming up. Yeah, you might want to hit fast forward again. Okay, here's the video following the house around the site. Now I think the south facade of the building we're actually still working on. I think the north facade that faces the roadway is a little bit more resolved, which is what I'll show you next. You can see that's a channel, a water channel, and on the other side is the Autobahn. Okay, if you want to hit fast forward again. Okay, so what we did to start to study the north facade of the house, you know, 400,000 or 500,000 people a day drive by the building on their way in and out of Vienna, and the clients wanted this to have a very strong presence on the site to the Autobahn because more people see it from there than will see it visiting it every year. So what we did is we set up a skeleton system, which again, I mean, we could go into it, but you set a series of parameters for every joint in the skeleton. And we attach the endpoints of that skeleton to traffic moving from the south and east of Vienna into the city, which is this, you'll see a kind of glowing ball move by in a minute. And then we attached it to another force moving back out of the city. And we gave those elements a force which decayed over time, so that it was a strong force in the morning dragging the skeleton, which then relaxed, is another force pulled it in the other direction and then relaxed. And because of these two forces pulling on this chain at the same time, it developed a kind of waveform where it was pulled very tightly at the upper left piece of the site towards the city, but then it was released more towards the lower part because of the angle of the Autobahn. And so we developed this kind of skeletal shape of motion throughout the day, and again we were faced with the same problem about where would we stop it, what was the ideal point of freezing it. So we attached a whole series of surfaces to it and started studying the deformation of those surfaces on the site, and then with the software started just driving cameras by and trying to make our own evaluations about optimal points. And finally, we had the idea to, I mean, they aren't really pencils, but basically attach tiny little pencils to the tips of all the skeleton pieces and have the tips of the skeleton draw a series of surfaces in a series of lines in space as they were dragged. And then we built surfaces out of those splines. And that's what you see here, is a whole series of bays of each one of those skeleton pieces being dragged through space. So I don't know if people know the photography work of Etienne Jules Mouret, but he used to call a certain kind of photograph a phase portrait, meaning it was a portrait of a sequence of time in space rather than a series of stills like Muybridge would shoot. So the idea here was, instead of freezing the surface at a point, we would capture a motion surface through time. So each one of these bays is running from 12 midnight to 12 midnight in its motion. So the north facade sets up a condition where you'll see right here, as you're going into Vienna, the surfaces, shoot, I think you'll see it. Well, this is a view coming back out of the city. But as you come by the building in the morning, all the surfaces flare and open up at the lower portion of the building. And then when you come back out at night, all the surfaces open up and flare in the other direction. So that the same set of surfaces open in two directions based on how you pass it on the highway. So you'll see, right here is what you see coming in, and you'll look into the building on the low side. Here's what you see coming back out, where you get a very different situation of openness of the building. For the exhibition, you see, actually if you could back that up a little bit. The hydrogen fuel cell sounds and is very exciting as a technology, but as an aesthetic, it's the size of a small refrigerator, and it just sits in a box with Siemens printed on the side of it and doesn't really do anything. So the real challenge for us with the exhibition design is to show interactively, okay, you can just let it play from there, to show interactively what's going on with this technology. So we set 2 zones in the building. One zone is along that north wall, which is loaded with all of the mechanical systems of the building. The other zone is the exhibition part of the building, which is all interactive displays. So when you come in the building, you come in on the right side of that glowing surface, and it's a tensile structure which has rear projection equipment that displays images on the surface. And you'll actually interact with the displays by pushing and pulling on the surface. And it's dark in that zone that's to your right now, which is where all the mechanical equipment is. But then at the end of the exhibition hall, the lighting is flipped so that it's dark in the exhibition space and bright in the mechanical space, so you can look through the tent and see a lot of the mechanical systems of the building through the surface. Now this is a view moving towards Vienna, I think twice, then moving back out again. This was when we were looking at some fairly radical budget cuts which lopped $1.5 billion off the building, but fortunately we convinced the cost estimators to be a little more reasonable, so it's back to its original size. And I think there's then one more. The structure of it is all glue laminated beams. We found a glue lam fabricator outside of Vienna who has a computer-controlled jig, where usually the economies of glue lam production is you have to first build a template in steel and cast the wood beams against the steel template. But this fabricator has a jig with pins on threaded rods that's computer controlled. So every single beam in the building, we just give him a CAD file. He sets the jig and casts a glue lam beam against it, takes the glue lam beam off, and recalibrates the jig. So when we asked if there was any premium for having a different shape for every beam, he said that shape has absolutely no influence on the price whatsoever, that he just takes all the pieces of structure and puts them on a scale and weighs them, and it's like bananas. As long as every member follows within a certain set of parameters of how much it can curve and how long it is, he doesn't really care what the particular shape is at all. It's just a question of mass. And then the skin is a zinc panel system that goes over. It's all ruled surfaces, so the secondary structure is all light steel. And then there's a series of zinc plates which overlap differentially to make the surfaces. This actually is, if you pause it, it's off the page, but there's first the zinc surfaces, which are drawn in a planar way as those 8 or 9 strips. Then the secondary framing as it exists topologically, and then on the right of that flattened out into planar elements so we can dimension it. And then next to that is the ceiling surface, which is all routed gypboard that they put plastic tubes in, and they heat and cool the house with like little plastic fin tubes that are embedded in the plaster walls. And then you can see each one of those panels flattened out to the right of that. And then finally you see each one of the glue laminated beams on the far right flattened out. So this is the kind of drawing we have to do to go from a topological surface to a series of flattened components that can be fabricated. Okay, if you hit play. Then this is a section of that with the tent surface you see beyond the series of monitors above. That's the south facade with all the photovoltaic panels. This is the north facade where those curves come down and open up on the lower left. The 2 end elevations. Sorry about the quality of this, but I actually didn't have time to just shoot this stuff in slides, so it's off a screen. A series of butterflied sections where it's cut and you look both directions to the east and west. on the left and right, and then a final image of the project. So that's it. Thanks.
We have time for some questions?
Sure.
Could we get the lights over on the side there?
Thanks.
money gets spilled out.
Oh, that's a coincidence.
Okay, but we open up the questions? It's quite a crowd actually, going to have to yell. Jeff?
I wouldn't touch with a Jeff.
I mean, because you came back to it a few times, I'm wondering if you could say a bit more about how you, I mean, this game of having to kind of start and stop the animations.
Mm-hmm.
I mean, you say it as if they can't conclude themselves, I mean, in
Right.
a certain way. So, I mean, how do you do it? I mean, the implication seems to be that it almost becomes this kind of animation as a kind of story. I mean, an animation in a kind of more familiar way.
Right.
You know, kind of Disney animation or something. And is it a kind of attempt to resist that, like you don't want it to be a kind of self-contained story that the animation sits outside of, or is it you know, just a kind of operation where you just chop it on and off?
I mean, the way all the projects I showed you, the way they start it's never with form. It's always with forces. And I mean, that's basically the beginning of the problem. Well, I don't mean problem in a bad sense. It's the beginning of the dilemma in that, for instance, the site in Vienna or the church was all modeled initially with a series of forces and dynamic elements. And then we end up dropping surfaces or dropping skeletons into that situation and studying their behavior. And because we're not starting with a prototype or a form or a space, we're always looking for something to develop out of that dynamics. And that's the dilemma, is you work intuitively knowing that if you set up certain attractions, say, moving on the Autobahn, you know the surfaces are going to behave in such a way that they're going to register those influences. But when you bring the surfaces in, you have no idea in particular what they're going to do. And so the role of the designer is to tune the original parameters of the forces, constrain the surfaces with things like those skeletons so that they don't do something that's either, you know, unseemly or unbuildable or unfunctional. And you're basically working within a network of things where you're not in control in the classical sense. And so
It seems like a real fundamental shift that's more important than that. It seems to me originally you would model contingencies available from the context.
right?
And in that sense, that was the choose frame moment. So you would
Yeah, right.
model with some verisimilitude the contingencies in the context.
Right.
And then you would be, because those contingencies were dynamic, you would have to pick some moment which instantiates the dynamics.
Yeah, right.
And in that sense, you were still caught up in semiotic representation or narrative architecture.
Right.
Later on, you change the dynamics to see how the animation worked with the constraints. So, for example, the size of the site or the size of the gallery or the fact that the du buffet was covered or whatever.
Right.
So instead of caring about the verisimilitude of the constraints,
Yeah, right.
of the dynamics,
Yeah, right.
you just kept changing the dynamics until you got a relationship to the constraints that you thought was what you wanted. For example, you were able to cover the keyhole space.
Yeah, right.
So, I mean, what's interesting to me is that those are two radically different theoretical moments in the two. I mean, it's not simply, you know, I don't know how to stop one, so I'm going to change the, you know, at one point, the dynamics are crucial, and therefore
right.
they still maintain a semiotic relationship to the project. At the next point, as a designer, what you decide to change is the dynamics instead of picking the best frame. So,
Yeah, right.
I mean, whether it looks different or not, fundamentally in the projects they operate differently, and you know, it's two completely different,
Yeah, no, that's
say,
right.
intellectual positions about the work.
No, that's right. Well, honestly, to learn the software, it's at first always you just cross your fingers and hope you're going to get something, and the last thing you'd mess with would be the dynamics. But actually, the more I have and the people in the office have started to work with shaping space based on the parameters and the dynamics, the less we've had to freeze things and rebuild surfaces. I mean, in a way, it just means we're designing with the forces now as well as designing with the surfaces and forms. And
But it's force in, let's say, it's now force in a constrained context.
right. But I mean, there's nothing ever scientific about the way we didn't count cars in Vienna.
I think it's a big deal, though, to move from 1 sun to 36 suns.
Yeah, right. Absolutely.
Because that's a sort of design decision. The world would be better with 36 suns. From an architectural point of view, and just like I've always said, the night would be better without stars from a design point of view. All that decoration in the sky, is kind of irritating.
Well, I mean, it is a move away from a kind of. I mean, when we were working with the engineers that were calculating the solar loads, when we said, oh, well, now we're doing 36 suns, they looked at us like, there's only one. I mean, there's a notion that things like gravity force or solar force, or those things are absolute truths that you could reproduce or mimic if you were accurate enough and scientific enough.
I guess the point
And
I'm trying to
that's
make
not
is
the case.
process is getting more mature because you're not only contesting the habits of Cartesian reduction that you mentioned earlier, but you're also overcoming your habits of narratological processes and animations.
Yeah, right.
So all of a sudden the idea for you that you can have as many suns as you want instead of the narratological reference to one sun becomes an important moment.
Yeah, right. Well, I mean, there's no way that a person in a car driving by that building or a person walking up to the building and seeing the alignments of each one of the panels would ever be able to uncover the process that generated it. And that's actually not the point.
And in fact, as you'll see tomorrow night, it looks very much like a whale shark. And, but of course, it has to do with fish interpretation.
Well, see, this is the problem is
That's tomorrow night.
everybody always sees,
The shark.
well, everybody always sees signifieds in things, and there's no resisting that. I mean, but it's, I mean, that's a reading process in terms of the image of the projects, which actually isn't that interesting. I mean, to me, anyway, I don't really care what it looks like yet. I mean, a lot of the stuff is very, not ugly and not beautiful, just undisciplined aesthetically, because it's not being generated
I would
out
say
of...
that was a reasonable assessment.
Yeah, no, I know you would. No, I know you would. I mean, that's why I'm cautious about saying, like, any project would be reproduced as a space or a form, because honestly, all of them were produced in almost absence of those kinds of criteria. I mean, there's a certain elegance in the way surfaces get built. And when you look at a topological surface, if you have CVs and isoparms that run along the surface, and you have an inflection like a ripple, you want to put a lot of CVs and isoparms at the ripple, and you want to take a lot away where it's more or less flat. And there are conditions about just the quality of building a surface and the rigor of building topological surfaces that I think exist. And that's something where I'm constantly, being like a classical architect and saying to everybody, rebuild that surface, it's ugly, because you've got a lot of isoparms where it's flat and it's really craggly where it should be inflected. And so, we'll go through and rebuild things and aestheticize at that level, but it's just about basically rigor of surfaces. I mean, like we were car designers or something. We just know what makes a tighter, better surface. But in terms of the overall image of the projects, it's a huge blind spot.
When you were talking about using the animation, it seemed to me that the first description is that there's a kind of research going on that produces revelations. So it's something exciting, interesting, whatever, and you take it as a starting point. Then, as you move along, it becomes that process becomes a sort of determinism. And so that, if Jeff said there's no longer this narrative, it seems to me that it's been replaced by a narrative, at least as a description, of determinism. That there's a kind of narrative that if you could just get all the parameters down, or if they're concrete enough, that actually, the determinism of the computer works it out as a form.
No.
As opposed to there being a kind of revelation about the organizational structure that emerges between conflicts in the animation.
Well, I mean, the computer as an intelligence that could be deterministic, it's just, with this software and the way it's being used, it's just simply impossible. I mean, because it's made for the special effects industry, It doesn't, you know, I mean, the problem is actually it has almost nothing to do with architecture, and you have to find a way to use it architecturally. So the idea that it would
The way you
be...
describe it is always as a kind of rastering of external forces which culminate in the production of an object.
Right, but I mean, that's a decision we're making as designers using the tool. I mean, there's no way you can study motion the way, you know, as quickly and have geometry out at the end without a computer. I mean, you can do like, this guy that did the, like, cymatics, I forget his name, but he does, you know, motion studies of a vibrating plate with sand, or he does slumping studies, yeah, Hans Jenny. He does studies of slumping mud structures in a harmonic field. And those kinds of things you can start to get at motion-generated form or dynamic-generated form. The problem with it is, and then you take it to a bandsaw and slice it up and put a pencil around it and trace it and resurface it or something. But with the computer, you can do that kind of research and always have the geometry and a planned section view of it while you're doing the dynamics, which makes it more interactive and basically more insightful, I think.
But I mean, the answer to your question is, like, you set up you set up a structure, you run the sun over it, you have get big, get little rules.
Right.
Okay, at one point you do that, you think, okay, you look at it, you think, okay, this is good enough. This is going to be good enough to get the sense of time embodiment in the form. You don't test, there's not like, let's try 20 of these and see which one I think is best. It's a kind of good enough issue in terms of the formal sensibility because you're not particularly worried about the aesthetic.
No, but we are worried about the aesthetic. It's just we don't have criteria.
Right. Well,
And the aesthetic decisions are basically like, it just ballooned to triple the size of our buildable square footage. So
When you see the first animation, you think, oh, this is great. That's it. It takes however long it took. It's not like, oh my God, do I need a typological basis for this? Or is there, what if I use the moon instead of the sun or something? You know, I mean, what does moonlight do?
No, that's true. I mean, one thing that's true is the first thing we start with, on every single project, is maintained at some level.
Because it's always good enough in terms of producing.
Exactly. I mean, there's no origin. I mean, it's not a problem that...
It's not really about, making sure there's not a revelatory moment in the sense of, my God, this is it, and this is the only thing. And it's always sort of, well, this is cool. It's kind of Wayne's World.
But there's a question. But there's a question of every. Because in one way, Don's question could be seen as a question about if something happens at one moment, what this does organizationally, i.e., with the plan, where the answer that you gave was that every plan works. Every section works, and one doesn't work in a different way or in a revelatory way
I think that's important. I mean, more than anything else, the notion of a kind of ideal revelation in the mind of God embodied in the hand of the architect, which leads to one perfect solution to each project, is undermined by the mind.
Yeah. No, I'm convinced you could even give me like...
Between revelation as a sort of absolute transcendental and just this is something we had never done before, and the process allowed something to emerge that hadn't existed before that one can then incorporate, as opposed to, because when you talk about gaining authority over the program in the office, there's a sense that now there's a kind of certainty about determining the parameters to greater and greater degrees as you go along, which to me tends towards a kind of determinism by being able to ascribe the possibility of those parameters. You can say,
Well, see, I just think this is a bad way to look. I mean, I don't worry about gaining authority over the software because I'm not interested in authority. I mean, I would say 51% of the projects are designed by the Alias Corporation and Silicon Graphics Incorporated, and that's fine, right? I'm not threatened by that, and when I approach the software, I'm not trying to figure out what I want the software to do. I'm actually, each project, trying to figure out what the software wants to do to me or to the office. I mean, so instead of approaching it like, we want this to model sunlight, we say, well, seeing as we can study solar force and seeing as we can make it deform surfaces, what does this want to do to the design process? And basically just take that opportunistically and use it very incrementally. But I mean, the idea that there's an ideal button or an ideal process that we would ever use twice, or that we would ever raise above another one is just, it's just not interesting to me. I mean, I would say...
Or even that there's a perfection. Let's say you don't argue that there's a perfection in the relationship between the 600-person wedding chapel and the 800-person dining chapel, whatever back.
It's totally contingency.
You're not worried about the perfection of that relationship through a whole set of studies of architectural, either typological, historical, processual, whatever. It's not a matter of perfecting some specific architectural moment, because in a certain sense it doesn't ever believe that ever happened or is significant to happen.
But why do you use the word perfection?
Because that's actually the implication of both of the questions you're asking. In a certain sense, you challenge him for interested in a kind of perfection which is not directly related to architectural criteria for value. For example, how well or poorly he handles the program. But there is a casual attitude in the architecture about, for example, those issues that we would normally use to evaluate the program. How it looks, how it performs, how it relates to the context. It's quite casual. So you have no sense of where he's exercising any judgment until the fact he says there's a kind of...
Continually.
Yeah, you're exercising continual judgments about certain contingent conditions.
Yeah.
But then when you want to realize that, you exercise a kind of precise, rigorous judgment of the materialization of the project. So everything else remains either good enough or flexible. I really think that's I don't know that I agree with it in Greg's work, but I think that's the most important part of his work, really, is a real abandonment of a set of criteria for what constitutes precise judgment in architecture, and in a certain sense of realism. I mean, it's realistic in the sense that those relationships and those questions of materialization end up being perceptually more verifiable than any of the ideas of perfection in program, for example.
I mean, the big aesthetic and programmatic decisions that were made on, let's say, the church was the choice of the software and the choice of the relationship. And I've said this before, but everyone in the office said in the first meeting with the clients, first everyone had a lot of anxiety about showing them computer images, and that's why we built that little cardboard model. It was honestly a really trashy little model. It didn't tell us that much. But we built it because we needed something to show them, and everything had been done on the computer. And so the clients came in, and they saw this little model, and they thought, this is it. We expected a lot more. And so in a panic, everybody moved away, and we showed them the computer stuff. And all we showed them were these blobs expanding and contracting and generating this surface on their building. And honestly, once we explained what was going on, they understood schematically our design process to the point where the Reverend immediately said, make the altar stronger, because the objects weren't making a single surface. I said, well, we have to spend more time to get these things to stick in a single surface rather than in groups. He said, make the altar stronger. And we said, well, you make the altar stronger. And he sat there with the mouse and turned the altar up so the thing snapped together and broke into pieces. And I mean, that level of design, I think, is important. That with a system like this, I mean, it has nothing to do with the animation. It has more to do with the fact you're dealing with parameters and flexible surfaces. You just develop a schema, and you give the schema out into the world before the building's done. And the clients understand it, the authorities understand it. I mean, it's just more, is a diagram, they see what's going on, and they don't read space just in terms of the aesthetics. And I'm fairly convinced still that the treasurer, the secretary, and the reverend of this church still don't have any idea about the aesthetics. And they think they're slightly troubled by the aesthetics. I mean, as is the design team. But I know they understand the process and the schema. I mean, they understand theoretically the importance of the schema in our design work, too. And so the fact that you, instead of giving a design and saying, isn't it beautiful, or doesn't it function well, or do you accept this, you put a schema forward way in advance of that, and it just makes the whole situation much more workable. And I mean, I think it's a more optimistic relationship of what architects do, which is make diagrams and schematics rather than buildings. I mean, I would honestly be perfectly happy, doing the initial design work and, setting up bigger team structures to actually realize the buildings, because I think a lot of the energy is in the schematization. So, I mean, that's honestly where I personally put my energy. I mean, Mike or Doug would tell you something else. because they're plugged into different aspects of the project. But
I don't want to be too cynical, but I'd like to put the question whether there's any major difference between the intention behind the design of this Art Deco building in New York and your visitor center in Vienna. As you explained, they put a clock on specifically to catch the attention of the continuous stream of train journeyers. And no doubt the designers did their best to make this a very imposing monument of their time. Now, you are doing something very similar. You went to extraordinary trouble, as you proved tonight, to get the maximum impact. And you studied the movement backwards and forwards of the car traffic, so that this building, again, has the maximum impact. Now, this raises, I think, quite an important issue, because architects in general are really a kind of slaves to the systems in which they operate. You are, I think, well, I'm asking you what you feel, but there is a trend here that you are maximizing on a position in order to get the building as an attractor, yeah, for powers far beyond you, yes? And the techniques that you use very cleverly and to some extent perhaps in an original manner are still the techniques which are basic to the broad stream of our existing society. And our existing society is in deep trouble, as you well know. So these issues, which are now widely discussed, especially in the British press, morality, what is the purpose of all this? Are these the kind of questions that are relevant to this evening's discussion, in your view?
yeah, well, I believe a certain alignment with basically a dictate of the building. Its primary function is to be a visual presence from the Autobahn, which is, that was the instruction that we got in the very first meeting with the clients. The fact that we accepted that, I don't think is necessarily a bad moral decision. It might make it suddenly a building that wants to announce its presence, and that might be a bad moral thing for architects to do because they should be humble. But honestly, the client hired us because they said it should be a strong visual presence on the site. And that's the reason we designed it that way. The church, for instance, has almost no visual presence to the front of the site. It's all on the back where nobody sees it except people from the interior. So that was basically something that we just inherited with the project. It was part of the structure of it. There are all kinds of moments for criticality, though, throughout the whole design process where we decide to, try to change a client's directive, or we try to be critical of the process. But the fact that it should visually announce itself wasn't something we thought was worth changing.
Do you think society's in deep trouble?
Well, it depends.
Yes or no, do you think society's in deep trouble?
I don't ever, whether it's absolute questions about aesthetics or absolute questions about society, relative to what?
Well, he said, as we all know, society's in deep trouble. I don't agree with that at all. I just wondered if you would.
Society's always in deep trouble.
Society's in deep transition, and the society that we know is not going to be here, so it's in deep trouble.
Well, I think...
But the one that's going to come is going to be damn happy that the last one was in deep trouble.
Well,
You got to be careful that a certain habit of persistence doesn't become metaphysically theologized. Now, for example, I'm sure that the dinosaurs thought, oh shit, we're in deep trouble when the asteroid hit. But all the shrews and the mammals thought, thank fucking God, the dinosaurs are gone. We got a chance now. So I think you have to be really careful that every project that every innovation or experimentation with novelty doesn't hit the wall of not solving the problems of a society in deep trouble.
Well, there's mostly just because of an arbitrary date. I think there's a real... No, because of the year 2000. There's a real interest in the work we're doing right now. And it has nothing to do with, a kind of millennial new ageism of us, but it definitely helps us do our work. And there's a general level of anxiety about I mean, that's what this soil company is doing, is they're looking at alternative energy sources for the first time and trying to figure out if they're financially feasible, because they know there's a market for it. And I mean, I think if there's a market for hydrogen, that's not a bad thing to do a thing that promotes hydrogen energy. I mean, it is for a multinational corporation, but I think it's difficult to say, well, we're not going to work for multinational corporations even when they want to do hydrogen fuel cells. I mean, it's a complicated time to make ideological arguments about architecture, because I don't think there's a clear, you know, formalism of progressive ideology.
It never has been for architecture. Architecture has absolutely never been a friend of revolutionary progress. That's, you know, it's always hanging around with the rich, powerful people. It's always, you know, hanging around with the evil guys. You know, it costs a lot of money to do this stuff. It always symbolizes power or presence. Architecture just, you know, there's no good way to get around it. You need a lot of money to build, and people with people or corporations with a lot of money like a lot of presence. You're always going to be on the corrupt, evil side of things.
Yeah, not when you do a church.
Yeah, the Korean church.
That's a lot of people with a little money.
It's like Sun Myung Moon or that kind of stuff.
Okay, let's do one last question. Christian?
Yeah. Now, if I understood you correctly, this meta blob, as you called it, this is commercially available software that runs on SGI.
It runs on everything. It runs on AutoCAD.
That doesn't matter. But my question is, I mean, perhaps slightly similar to the way that Le Corbusier developed the modular, which became such an important part of such an important tool in his work. Have you ever thought, instead of perhaps, you know, you found that MetaBlob takes these blobs, as it were, and is able to, through gravitational fields, merge them into these forms. Have you ever thought of trying to commission or develop your own tools that would in a much more direct way embed your design philosophies, rather than hoping or relying, shall we say, on finding something like MetaBlob that happens to do that? But as you said, you see what the software does. But
I mean, my strategy has been that I try to get as much software as possible for free, and I try to be, you know, I try not to invest heavily in anything that costs more than a couple of $100s.
You go to Hong Kong much?
And I just try to, you know, basically use software for what it's good at, which is what, I mean, everybody that uses software intensively, I mean, like the film industry doesn't just use one software. I mean, they model dinosaurs in AutoCAD. And then they take AutoCAD models of dinosaurs into Alias and give them skeletons, and then they take them into soft image and render them preliminary for lights, and then they take them into RenderMan to do the final renderings.
I'm sorry, can I answer one thing?
But anyway.
Because, I mean, this persistent myth is just what you say is just not true. What you say is just absolutely not true.
There's a question I was thinking.
No, but you say Korb developed a modular, and then so doing, embodied his own theory, developed his own tool, did not rely on on general production tools to do his architecture, which therefore gives his architecture greater heroic individuality and significance. This was the basis of your argument.
I thought it was a critique.
I don't know enough about the modular to make a statement. Like,
Well,
to argue with you about it.
Yeah, but
I'm just asking Greg here. It's not about the modular. I'm asking him if you would find that you would have more flexibility or more direct control over what goes on within the computer if you had an influence into what actually goes on.
No, I mean, honestly, the people that give me the software I have a fairly good relationship with, to the point where already I'm seeing things that we ask for in, you know, I mean, the other direction where I'm sure the next whatever, you know, T2 movie or something will have things, or, you know, you tell Chris Yesios he should get tools on Form Z, and, you know, all of a sudden you see this stuff on every architect's desk. So,
It's the fur is the next thing.
yeah. So, but anyway, I mean, what I try to do is just get access to what's commercially available, because it's, you know, I know, well, actually, I mean, it's probably not bad to talk candidly, but Bernard Cash is somebody that I think was so far ahead of what was going on 5-10 years ago. It was amazing. And he has this moral belief, despite the fact that he's a diehard Deleuzian, that he shouldn't use anything he doesn't invent himself, because it's not honest. And so his work is, you know, he has to write every piece of software. It would be like if you had to whittle every drafting tool on your desk instead of going and buying a triangle at, you know, whatever the, the Triangle Bookstore or something. I mean, it's, I just don't have that kind of authorial relationship to the work where it's important to me that I design it on my own software. I would rather have the software designing on me. And I would invite, I always invite new kinds of software just for the sake of finding out what it wants to do, rather than say, well, this is what I want, it's the blobular man, I'm going to define it once and for all and franchise it, and it'll be the best organization for all eternity. I mean, that's not a, I don't know, I'm not interested in that kind of relationship to the work as an author.
It's also not true historically. It doesn't hold up. Corb had a modular rule made for everyone in his office. He handed them out. They did the work for 2 months. He looked at the work. He thought, my God, this is a complete nightmare. And he gave everybody else back their rule. It's just, and not only is the Fibonacci series not core, and the modular idea not core, but it was generic. But even when they tried to make a tool which kept it a rigor in the office, it didn't work. So there is not, the only place I know of the myth of a truly invented instrument is in the myth of Daedalus and his nephew. It's in myth, the sort of myth of the saw and the myth of the compass. You just glue lamb. Can glue lamb is sort of more interested in writing your own program.
So you definitely see a separation between the tool maker and the tool user.
Absolutely.
Point on this, Chris. I don't think it's actually that your philosophy is being made by the tools you can develop. You were talking about the triangle that used to make, that's what made competition make everything going like this. Whereas now you're using a series of tools that suddenly let you invent technological art.
Absolutely.
So it's the tools that are creating you, not the other way around.
Exactly.
Right. So I think what Chris is trying to say is, isn't it better if we could make tools that would let us, obviously the software writers who are making these tools, well, maybe they're better architects than people who are just using them as.
But where do you stop? With clients?
What's interesting is that he's not using architectural software tools. One of the problems is if you try to use Form-Z, if you try to use one of the computer tools that have been developed by architects for architects, then you run exactly into the problem you're talking about.
Well, that's because the people who develop tools for architects have a strange idea of what architects are about.
No, it's even, I was on this panel with a guy named Alvy Ray Smith, he wrote the algorithms for Toy Story. He used to be a PhD at Columbia, heading up the mathematics department when he went out to do Toy Story. And I said, how could you possibly leave a doctorate, a tenured doctored position at Columbia to go do cartoons? And he said, well, I've been looking at your work, and I think, I'd like to give you a card. You could have a career in the cartoon industry. And he said, it's really where all the action is. It's so much more exciting than architecture. It's so more exciting than being a head of a department at Columbia University. And I'm really doing pioneering work there. I'm looking at all kinds of algorithmic systems that I never got funded to do. And in order to do cartoons,